Hello, everybody. I'm going to be presenting Sprint 23. So the question reads, integers m less than n satisfy the below equation. Compute the remainder when m is divided by 100. So what are we going to do? Well, there's a lot of square roots here. So one thing that we probably should do to make this a little bit easier is to square both sides. So when we do that, we get m plus n plus 2 square mn is 5 to the 12th plus square root of 5 to the 24th minus 1. And 5 to the 24th minus 1 is not a perfect square because 5 to the 24th is a perfect square, and therefore 1 minus that will not be a perfect square because it's such a large number. So we can reasonably, or so now like we know that mn is equal to 5 to the 24th minus 1 divided by 4. Make sure to square that too. And m plus n is 5 to the 12th. So now we want to find m first of all. So we'll do this like, this is kind of a classic problem, I would say. So first of all, we're going to square m plus n, and then we're going to subtract 4mn from that equation, and it very conveniently works out as 1. And then we square root this, and now we need to decide, is n minus m equal to 1 or negative 1? Well, since n is defined to be bigger than m, we know that n minus m is positive, so we're going to take n minus m equals 1. And finally, we want m, so just solve the equation, and we get that m is 5 to the 12th minus 1 over 2. However, we're not done because the problem is asking for the remainder when m is divided by 100. So that basically brings me to the next main step in the problem, which is how do we find the remainder when this is divided by 100? And so to do that, we're going to, again, like last time when Edward presented, we're going to use the Chinese remainder theorem. So actually, this divided by 2 thing is kind of annoying. So instead of finding m mod 100 directly, we're going to find 2m mod 200 first of all. So 2m is just this numerator part, and 5 to the 12th is obviously like 0 mod 25 because 25 is just 5 squared. So 2m is congruent to negative 1 mod 25, and then 200 is 25 times 8. So we also need to find this mod 8. Well, using Euler's totient, 5 to the 4th is equivalent to 1. Or you can just say that 5 squared is 25, which is 1 mod 8. No matter which way you do it, you can find that 5 to the 12th is 1 mod 8. And so this numerator of the fraction is going to be equivalent to 0 mod 8. And now using the Chinese remainder theorem, we can find that 2m is equivalent to 24 mod 200. Now there are 2 solutions to this mod 200 in m. One of them is 12 and the other one is 112. But either way, we find that m is equivalent to 12 mod 100. So the answer is 12. Thanks, everybody.
This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.